faculty. We have two sessions today. Morning session is on passive optical network for 5G frontal hall by Dr. Simranjit Singh. And after that, we have afternoon session on 5G end-to-end call flow by Sri Rahul Kondal. He will be taking session from United Kingdom. So the second session has been shifted to 2:30 p.m. for the convenience to the speaker. Coming on to this session's topic, passive optical network for 5G frontal hall. I, on behalf of FDP team and participants, extend deep gratitude to Dr. Simranjit Singh for his effort to take this very pertinent topic. Before I hand over to Dr. Simranjit Singh, let me take the honor and pride to introduce Dr. Singh. Dr. Simranjit Singh is Associate Professor with his proven distinguished track record in higher education. He is PhD in Electronics and Communication Engineering, specializing in optical communication system from Thapar Institute of Engineering and Technology. Dr. Simranjit Singh is recognized among the top 2% most cited scientists globally by Stanford University and Scopius. He has received prestigious fellowship including the Raman Fellowship from UGC, Government of India, and serves as a host scientist of FICCI, Government of India, under the C.V. Raman Fellowship from Optical Researchers. As a principal investigator, Dr. Singh has successfully led 4 research projects valued at rupees 2 crore. His research group has contributed over 60 papers to esteemed SCI journal, demonstrating his commitment to advancing knowledge in his field. With a dedication to mentorship, Dr. Singh has supervised 5 PhD candidates, with 6 currently under his guidance. Notably, 1 patent has been published from his research group. Outside academia, Dr. Singh volunteers his expertise as the secretary of the IEEE Photonics Society Rajasthan chapter and as an executive committee member of IEEE Prakash Bharati. His diverse contribution reflects his dedication to academic excellence and community engagement. With this brief bio, I request Dr. Singh to take over the session. Dr. Singh, it is all over you. I'm making you the presenter.
Thank you, Sanjay ji. Thanks for the introduction. So can you please? Okay, I will.
Yeah, you are already a presenter. So please share your screen. Thank you.
Yes, yes. So I hope I'm visible to all.
Yes, sir. Yes, sir. Please go ahead.
Okay. Thank you so much. So my today's talk will be around 5G core and front haul, and I'll be talking about the role of optical fiber communication in 5G. And in 5G, we mostly use passive optical networks. So in this seminar, I will discuss about the different visible light communications, optical fiber communication, passive optical networks, which can be used for the front hauling of 5G technology and which can be used in the 5G core. So before starting this session, I would like to thank Ashok ji, Sanjay ji and team who have invited me for this talk and given me opportunity to present my work in this esteemed FDP. My broad area of research is electronics and communication engineering. Specifically, I'm working on optical communication networks. When I have started my master's thesis, then at that time, I was looking for a good topic. To whom should I research? And there were several topics at time, like antenna, wireless communication, image processing, and optical communication. Then I chose this area of research because this area is having a very good future. Because wireless communication networks and all are very saturated areas, means if you want to do something new, then it is very tough. And optical communication network is open area of research. So whatever you think, you can implement. So I also have gone through this research paper, and that was my motivation actually. In 2011, before starting my PhD, I read this paper, and in 2011, Matsuka et al. Have predicted some counts. They have predicted that by 2020, the requirement of the capacity, code network capacity, would be around a terabit of per second speed. And so for wireless network, it's very tough to handle. It's near to impossible to handle that much capacity, the terabits per second. So we need a medium which can accommodate that much capacity. So optical fiber is the medium which is having large bandwidth. It is having around 360 nanometer of bandwidth, which can accommodate that much users, that much capacity. He also have predicted that by 2030, we will be dealing with the around petabit per second of speed. So you can imagine that right now we are dealing with the terabit per second of speed in the core network, but in future it will be petabit per second of speed. Do we think that the available bandwidth will be enough to accommodate that much speed? So I would say it's very difficult, because since optical fiber is having a limited bandwidth. Okay, right now we are saying it is having a huge bandwidth, but in future it will have a limited bandwidth. So there are some issues which we need to solve specifically for 5G and 6G technology, since we will have millions of users which will be accessing 5G or 6G. So for that we need to efficiently utilize the bandwidth. So there are several ways to efficiently utilize the bandwidth of optical fiber. Like there are advanced multiplexing techniques, advanced modulation techniques. Right now, the researchers are working on multi-core optical fiber. There are other fibers which are on the way to fabricate to accommodate that much capacity. So basically, what I want to say that yes, we have a good bandwidth, around 365 nanometer bandwidth for the communication. But is it enough for the 6G technology or 6G or beyond or 5G or beyond? I would say we need to see about this concern. We have to research on this, that how efficiently we can utilize the bandwidth. Other advantage apart from the bandwidth, there are other several advantages of optical fiber, like high speed. It is having lightweight, small size, immune to electromagnetic interference. So these are the important advantages of the optical fiber. But yes, I had a discussion with someone. He said optical fiber communication is very expensive communication. Yes, optical fiber is expensive than copper cable, twisted pair cable, and wireless. But if you talk about the per channel cost, okay, since optical communication is accommodating thousands of users, per channel cost, it will be much lesser than the other type of communication systems. One time installment is maybe very expensive, but ultimately per channel cost will be less as compared to other communication systems. There are different challenges in optical fiber communication, like how efficiently we can utilize the bandwidth. We need to accommodate high capacity. Apart from the capacity, we also have to see thus information security. Okay, so there are several ways to secure the information. One is we can convert the optical signal into the electronic form, and we can perform some algorithm on it, encryption. You can say that. Then after we need to convert again to the optical form. So there is a OEO conversion, which is time consuming and which is expensive also. So we also have to see some concern that how all optically, without any conversion, we can perform encryption. Of course, transmission distance is also a concern, since if we want to connect two different countries, then obviously we need long distance communication. We also need to see the different components like optical amplifiers for that, OADM, optical add-drop multiplexers. So these things we will discuss in this seminar. I think you have gone through about this generation from 1G to 6G. Okay, basically, it is the trend is changing because of us only. I would say, like, if you want to do research, if you want to start the research, then we also think about the ecosystem. We also think about that how, like, frequently we are using the natural resources. ultimately, like if I am sitting here, I'm using my mobile phone, I'm using my tab, I'm using my laptop and other electronic gadgets which are connected with the internet. I'm not a single user. I may be four or I may be five user. You can multiply with the crowd who are using internet and the electronic gadgets they have. So means ultimately we are changing the demand. We are changing the trend. And because of this trend, we need a new communication system. If we need a new communication system, ultimately we need new components. And वो कहाँ से fabricate होते हैं? It will come from the natural resources. So we need to think about, we need to do research sensibly that how we can do the research which is eco-friendly, okay, without compromising with the performance, of course. So you can see here that we have started from 2.4 kbps of speed, and right now we are dealing with the gbps. If I talk about the user speed, not the core network, but yes, in future it may be terabit, it may be petabit. Okay, it's depend upon the trend which we are actually changing. So if I am presenting the cell in 5G technology, okay, it is in hexagonal form because it can efficiently cover the geographical area, and we are having intercell interference. Okay, so we have to remove this intercell interference. Of course, it can be removed if we can use directional antennas, but yes, if you want to cover the whole geographical area, then we need more directional antennas to cover it. But of course, we need to reduce this intercell interference. Okay, so since it is a wireless, of course, there will be other effects also. That is not part of my talk, but just for the introduction, I have included this slide. So this slide is showing different architectures of 5G and beyond applications. So you can see here that 5G can give you can give the the services to the smart healthcare, smart industrial, smart traffic, smart agriculture, AR, VR, smart home, and many other applications. So why I have mentioned this slide? Because somewhere we need a real-time transmission. For example, robot surgery. For robot surgery, we should have a perfect connectivity. If we only rely on the wireless communication due to the different undesired effect, there will be a delay in the performance. So if we can use the visible light communication or optical fiber communication, then we can go for the real-time transmission. Okay, so there are different applications which are very sensitive to the time, which are very sensitive to the delay. So optical fiber communication and optical fiber is a very important part of the 5G technology. In future, I'll show where we use the optical fiber communication commercially in 5G technology. So you can see here that we have a different type of connection. This is the 5G network using drones. So I have seen the list, the components which we have received for the 5G labs. There is a 5G drone also, which can provide the 5G connectivity. Okay, so you can see the different altitudes at which we can install the drones. Okay, and you can see here we have FSO. FSO means the free space optics. Okay, which connect the core network to the one point to the another point and to the other drones. You can see, and there are RF signals also. Okay, so you can see here that the connection between these terms can be the RF signals. So basically, wireless communication system is also very important. RF communication, optical communication is also important. So we need to go for a hybrid communication in which we can use optical communication and RF signal communication. In another architecture, so you can see here that we have a different type of technologies to support the optical fiber communication. This is a radio over fiber. This is very, important technology in the field of 5G. You can see radio over fiber means, can we send the radio signal over the fiber? Initially, I would say no, because optical fiber only accept the light signal. The another question would be, can we modulate the light signal by radio frequency? Means that would be the analog modulation. Yes, we can. we can modulate the radio frequency signal over the light signal. Then further we can transmit through the optical fiber. So this is very important technology for the 5G technology, specifically for the front hauling, where we have a huge number of users we need to accommodate. So there is a optical fiber loop which connects the different data centers, different networks. So the optical fiber communication is actually the communication where we don't need any it is partial to the protocols. So it is immune to the protocols. Just we have to convert it to the light signal, just send it. Yes, we need to do the processing at the electronic part, at the computer side, we need to process it. But this is, you can use like one signal maybe not return to zero modulation, another maybe return to zero. Even we can go for the mixed type of modulation in the case of optical fiber communication. So optical fiber communication transparent to these things. It just needs a light signal and we can transmit through that. So if I talk about the capabilities in terms of ultra fast and large capacity, so 5G provides 10 to 100 Gbps. That is for the holographic communication, which is related to the media. It can provide 50 Gbps. That is for the remote monitoring, remote control for the automotive applications. Can provide 10 to 100 Gbps for smart logistics. Several tens of Gbps for the remote surgery, as I already mentioned, and 48 to 200 Gbps for the video transmission. Several tens of Gbps for low to medium orbit, and 10 Mbps for the natural disaster prevention. Means optical fiber communication can be used for the communication in the different applications, which is having different capabilities. If I talk about the latency, okay, the 5G provides the latency in orders of millisecond, also in the several milliseconds. It's depend on the application which you are choosing. Like for 100 millisecond, that is for the remote control system. 1 millisecond for the remote monitoring. 100 microsecond for the local communication. So these are the capabilities, some major capabilities of 5G technology. This is the slide which presents the application of optical fiber communication 5G technology. Whenever we want to connect the BBU with the RLH, then we can use optical fiber communication. For the high capacity communication, where we want to accommodate a huge number of users, we can go for the optical fiber. Okay, particularly the connection between these two can be the optical fiber communication. So not only the point-to-point optical fiber communication, there will be a multi-point communication. Okay, maybe one point to multi-point. Okay, multi-point to multi-point. Okay, there is no any point-to-point communication. So for that particular area, we need to go for the network. Okay, so passive optical networks is the technology which can accommodate this type of demands. I will discuss the passive optical networks in future. So if we want to connect the BBU with the RH, we need optical fiber. And for particularly if I talk about the technology, then we have to go for passive optical networks. Nowadays, we are talking about the 5G network also, like 50G, 60G, NG-PON2, NG-PON1, NG-PON3. There are several subtypes of passive optical networks which we will discuss in this presentation. One of my PhD students working on this topic, multi-band optical communication system. As I mentioned, we have around 365 nanometer of available bandwidth, including O band, E band, S band, C band, and L band. These are the bands recommended for the communication because it is having less attenuation as compared to other bands. So efficiently, if you want to go for the optical communication, then we have to go for these different bands. Okay, popular band is C band, or C plus L band, then C plus L band. But yes, if still we are lagging, then we can go for E and O band also. So the thing is how efficiently utilize we can this 365 nanometer. This is the big question. Okay, so my PhD researcher is working on this topic, and she has simulated, I think around thousands users using OptiSystem software, and in which we choose 100 gigahertz of channel spacing, and all the channels are distributed over all the bands O, E, S, C, and L band. Okay, so what we did, for example, I want to analyze the OSNR. We have used non-turn to zero with 10 Gbps of speed per channel. If I want to see the OSNR, optical signal to noise ratio, that how much noise is involved in the optical signal, and this is my frequency, for example, O, E, S, C, L band. For example, I am getting, low OSNR here, but high OSNR here, like this performance. And what I can do? I can do that I can increase the bit rate of this, but not this particular, where the OSNR is high. I can reduce the bit rate of this particular band. Why? Of course, if we have a good OSNR, we can increase the capacity, we can increase the bit rate for that particular channels. Okay, in that way, you can, yeah, by varying these bit rate, you can have a acceptable performance with high speed. Okay, so we have done till now. The further what we will do, we will use the machine learning to decide this, because right now we are doing it manually. But of course, we can go for the machine learning or AI technologies, which can be used to predict that yes, this is the OSNR, we can increase that much speed. This is the OSNR, we should reduce the speed. So that's how we can. What we want? We want that if I am sending the data over the O band, then I need acceptable performance. Acceptable performance means it should be 6 quality factor, greater than 6 quality factor. If I talk about the beta rate, it should be less than 10 to the power minus 9. So accordingly, we can decide how we can vary the bit rate over the channels. One of my PhD candidate is working on this research area, visible light communication, 5G technology. So the idea is that can we use the LEDs for the communication purpose, which can provide the light, which can provide the data. So it would be better. If I talk about the hospitals, RF signals are not recommended for the patient who are serious. So we can go for the visible light communication, which can provide the dim light, and which can also provide you the data. So also with high speed as compared to the wireless communication system. So this is the another solution in 5G technology. Specifically, if I talk about the indoor applications, we can go for visible light communication systems. The visible light communication simultaneously provide data transmission and room illumination. This is the advantage of visible light communication. So this is the basic architecture of this visible light communication. You can see this is baseband processing. Yes, this is electronic processing. We can process the input data, then we can convert into digital to analog. Further, it can give to the transmitter, and in the case of visible light communication, we can use LED as a transmitter. Maybe the combinations of LED array, you can say that, and we can directly modulate that analog signal. Okay, we can directly modulate the LED lights by using the analog signal, which we got from the input side, and further it can be transmitted to the room. Okay, this is indoor application. Outdoor application, I would say it is difficult to handle visible light communication in outdoor applications, but yes, for indoor application, it is having a huge scope. So we can use, photodiode to receive the optical signal, and we have optical domain at this side. Then we have to convert into the analog to digital form. Optical signal is an analog signal. Why we need to convert? Of course, at the end user, we are using electronic gadget, and electronic gadget only understand the digital data. So we need to convert. That's how it works, visible light communication. But it's easy to say, yes, simultaneously transmission of data and room illumination. It is very easy to say, but it's very difficult to implement. Okay, there are huge advantages, but there are disadvantages also. So you can see the second diagram. If I use LED modules, first module, second module, third module, so you can see there is a interference, co-channel interference. So we can remove it by optimizely decide the location of the LEDs. Okay. So this is another type. We can say it is a MIMO, multi-input, multi-output. Here the different LEDs are transmitting the same data to a particular receiver, because nowadays we are talking about the mobility. We want to move inside the room also. I'm taking laptop from one side to another side. The big problem in the visible light communication is obstacle. If we have obstacle, even any obstacle, it can, like dust particle can affect this communication system. If you want a real-time transmission, then we have to go for multi-input, multi-output transmission. If I'll compare VLC, RF, and infrared, okay, so I'll discuss the important parameters. Bandwidth. The advantage of the VLC is the bandwidth is unlicensed. You can use with free of cost. If you want to go for a RF, then we have to buy it. If I talk about the power consumption, visible light communication has low power consumption as compared to the RF. In the case of visible light communication, we have no EMI, electromagnetic interference. But yes, in the RFs we have. If I talk about the per channel cost in the visible light communication, LEDs are very cheap alternatives for the data transmission. It is having low price cost as compared to the RF. Yes, where we are lagging in the case of visible light communication in terms of limited mobility. But in the case of RF, just due to the scattering, due to the diffraction, due to these undesired effect, anyhow the signal will receive. But in the case of mobility, the signal can be absorbed by any obstacle. So this is a problem in this visible light communication. Of course, there are several solutions on which we are working on. So in the case of, if I talk about the health risk, visible light may have effect on eyes, but in the case of RF, there are several health risks as recommended by the doctors. But the governments are carefully choosing the frequency. So this is a wonderful job done by the governments, because they are carefully choosing the frequency and power of the signal. Li-Fi versus Wi-Fi. And Li-Fi is basically the light fidelity, which is substitute of Wi-Fi. Light fidelity means we are using light signal for the internet connectivity. If I talk about the speed of Wi-Fi, it is around 11 to 300 megabit per second speed. But in the case of Li-Fi, we can have 10 Gbps, so it may be more. And if I talk about the security, since we are talking about the indoor applications, and the light signal can be absorbed by the walls, it will not go outside the room. So in that way, it is secure. But if the hacker is sitting inside the room, then there will be a problem. So that's why I already mentioned that we have to go for the security, all optical information security. If I talk about the bandwidth, Li-Fi is 10,000 times broader than Wi-Fi. Okay, so interference is very less in case of visible light communication. There is no any electromagnetic interference, but yes, in the RF communication, it is present. Issues and challenges in visible light communication. The issue is flickering. Okay, flickering means on-off mode. Whenever we give the on-off keying, you can say that. When we give 1, there'll be a light. If we give 0 bit, there'll be no light. Okay, and this flickering may hurt the eye. So this means there are solutions. We can use multiple LEDs flickering on high speed. जिसको देख भी ना सकें. There may be a solution. Another problem is line of sight. If you want a perfect communication in case of visible light communication, then the transmitter and the receiver should be aligned to each other. There should be a line of sight communication. Otherwise, there will be no any communication. So that's why I have recommended that yes, we can go for the MIMO technology, in which we can use multiple receivers, multiple transmitters to transmit and receive the same data. Interference. Okay, sun is the bad source for this visible light communication because sun produces the light signals which can be interfered with the interface with the visible light communication. Temperature signal can also disturb this visible light communication. So we need to optimize the parameter if you want to go for visible light communication system. So the visible light communication, as I already mentioned, that is meant for the short haul communication. Yes, if you talk about the long haul communication, then we have to go for the free space optics. Particular type of laser we have to use, optimized power we have to use if you want the free space optics. Free space optics is basically used for the inter-satellite communication. Okay, where the hundreds of kilometers are concerned. Then we can use the high powered laser to transmit the data. So of course, that type of transmitter and receiver we have to use if we want to transmit that much huge powered signal, optical signal. So in that case, we have a the transmitter or central office unit which can process the data and which can modulate the data and produce the light signal. And for the light signal sent through the air, and at the receiver side, we have a splitter. So since we are dealing with the multiple user, in this case, you can say we have a remote units, different remote units. Okay, and these remote units can be connected with this central office unit by using this free space optics. In this, we have a splitter which split the data into the different arms. Okay, here we have a FSO, here we have a FSO, but here we have a physical component which is a FSO which receives the data, which split into the different. Of course, splitting means that I'm splitting the power only. I'm not using the filter here. I'm splitting the power. If I'm using, for example, here 150 channels, then there'll be a 150 channel, there'll be 150, there will be 150. But the thing is, we are actually reducing the power. Of course, at the remote unit, we have to go for the filters. There are different challenges in free space optics, like fog, which can produce mice scattering, rain, the water droplets can affect the optical signal, smoke, clouds, snow can produce the Rayleigh spectrum. So if I want to transmit data, okay, from one to another building, so there are tens of obstacles. Sun is one of them. So we have to do something. So to take up this problem, we have performed some experiments. I will discuss in future slides. So this is the setup which we have proposed in our lab. This experiment has been done by the BTech students. So you can see this is very simple and very cost-effective solution which we have produced. So this is my transmitter. That is my receiver. I'm using laser here and I'm using solar panel here. Okay, it is transmitting and it is receiving. So if we have an obstacle, this is my obstacle. If we have an obstacle, okay, then what we can do? As I already mentioned, we can use multiple receivers. This is the receiver 2, another receiver I'm saying. So we have used the motor, which is programmed by we have used this, what was the name? I forgot it. Arduino, yes, Arduino we have used to program it. Okay, if there is any obstacle, the IR sensors detect it. Yes, there is obstacle. then the motor will start rotating, and it rotate to the 90-degree angle. Okay, the receiver may be here, receiver may be here. We can, control the motor. So the receiver too will start receiving the same data. So that's how you can cater this problem, the line of sight solution. We also, one of my master thesis students worked on this topic, which is free space optics, and we have analyzed different seasons like foggy season, raining season, and all. So initially, we have started with this simulation, starting from Thapa University to Punjabi University, which is having around 10 kilometers, and we have varied the attenuation. Okay, so there are standards which are already published in many papers that yes, you have a that much rain, there will be that much attenuation. If you have a that much fog, there will be that much attenuation. So according to attenuation, we can see the performance. Okay, so see here we have a clear season. When we have considered zero attenuation, then we got pretty much good quality factor. But as far as the foggy season is concerned, rainy season is concerned, the performance is reduced. It is obvious performance will be reduced. Then what will be the solution? What we can do? In the foggy season, in the rainy season, we can go for the we can say that the repeaters. We can place some repeaters in between the transmitter and receiver. Of course, the cost will be high, but we don't have another solution. Either we can go for the hybrid FSO and RF signal. Okay, in that way you can work. But if you have a liberty to shift from GBPSP to ABPSP, then you can go for it. Another network which we have produced in the Patiala itself from New Green Park, Punjabi University, Tej Bagh Colony, Rajendra Hospital, and Tagore. This is a ring type of structure which we have proposed in our experiments. And you can see that the quality factor for foggy season and rainy season are above 6. For that particular setup, the performance is accepted because the thing is the distance between the different nodes are very less. But if we increase the distance, then we have to go for the repeaters. Another work done which we have published in a very good journal by one of my PhD students, that is orbital angular momentum states. We can say that it's a quantum states also in VLC communication, visible light communication. So you can see here, the idea is for the efficient utilization of the bandwidth. How efficiently we can utilize the bandwidth. Previously, what I did, that I have a one signal. One signal having different features like amplitude, like frequency, polarization. So I have modulated the data over each and every parameter of the signal. Okay, if I am modulating over frequency, modulating over polarization, modulating over amplitude, so I am modulating 3 data onto the same signal. That's how you can go for the efficient utilization of the bandwidth. Okay, one signal is accommodating 3 users. In this research, we have done the same, that we are using 3 different orthogonal modes to modulate the 3 different data onto the same signal. Okay, we have used RGB LEDs. Okay, and onto these LEDs, I am modulating 333 data by using different modes, by using this technology, which is OM. Okay, this is my one mode having L is equal to 0, M is equal to 0, when L is equal to 14, this mode, when L is equal to 40, this mode. When I combine these 3 modes, then this is the OM signal. 3 different modes into the one signal. Hello. So, we talked earlier. So here, these are the results. Okay, we have communicated over 1.4 meter, at which are very less distance, I would say. We want to increase this, but we are looking into the idea that how we can increase this. If somebody has some idea, please share with us. We can work in collaboration that how we can increase the distance. because LED is low powered signal, then what we can do means we have to discuss, we have to research on this. But yes, if I talk about 1.4 meter, that was the signal which we have transmitted at the transmitter side, and what we have received is showing. Okay, that is for the green light, that is for the blue light. Okay, so we are actually reconstructing the signal at the receiver side, and by using digital signal processing, and we are receiving the data, we are recovering the data. These are the eye diagrams. So I think maximum you know the eye diagram. It is basically present that yes, there is a 111000010, and this is 101. That's how it is present. Okay, if the eye is opened, then it means the communication is good. Okay, if eye height is reducing, if like this is my 0 1 is coming from this side, again going this side, and here something is coming like this, then there will be a problem. Okay, ultimately the quality factor and bit rate will be calculated from this IDAT. As I already have mentioned, the MIMO technology, yes, you can go for the multiple, transmitters, multiple receivers to for the efficient utilization of the visible light communication. But yes, of course, the cost will be high in that case. But this is the only solution till now which we can do. But yes, recently I have an idea. I'm working on it and I will patent it. Then after that, I can share with you also in the 5G group. This is the structure we have proposed in a lab. We have used Arduino and simple, electronic circuits, simple breadboard. And this project has been done by the third year students under my supervision. And we have performed this experiment over the 3 meters. And we have used RGB lasers. Experimentally, we have performed it. And we sent the data over 3 meters, and we have efficiently received this data at the receiver side. Yes, come to the another topic, which is very trending topic, which is millimeter wave. Okay, right now we are talking about the millimeter wave, 5G technology. So I already mentioned radio over fiber. Can we send the millimeter wave onto the fiber? Principally, no. But yes, if we can modify the millimeter wave, if we can modulate the millimeter wave over the light signal, then we can send. Okay, so the problem is how we can modulate this. Yes, we can go for the direct modulation. We can go for the direct modulation. Then that will be the millimeter wave over fiber. Many experiments we have done on this area. Passive optical networks is the network which is having passive components. Okay, of course, at the transmitter side, receiver side, we have to go for the active. But in between the transmitter and receivers, we have to go for the passive opticals components only. Okay, so the components which are involved in passive optical networks are OLT, which is optical line terminal, okay, which is a central office. ONU, optical network user unit, which is actually the user premises at the receiver side. Splitter, coupler we have to use splitter to split the power into the different directions. Coupler means if we are getting different signals from different sources and we are coupling it to one, that is coupler. And that another one is optical distribution network, how we can distribute the optical signal to the different networks. This is another component of the passive optical network. Under the passive optical networks, initially it was started commercially. It was started in 2004 when EPON and XG-PON, 10 Gbps PON was started. At that time, it was started with 1 Gbps and 2.5 Gbps, and it was shifted to the next generation passive optical networks 1. At that time, they were dealing with the 10 Gbps speed till 2015. Then in 2015 and 2010, we were dealing with the NG-PON 2, which is 40 Gbps of speed. And in future, we are working on NG-PON 3 and 50G network technology for 5G and 6G. This is the capacity trend in the passive optical networks. You can see the red terms are showing upstream and the blue terms are showing downstream. Okay, the passive optical networks is a bidirectional technology. we are using optical fiber as a bidirectional medium. Okay, we are sending basically at the receiver side, transmitter side, we are using transceivers, which is having capacity to transmit and receive the data. Okay, which have capacity to process the optical signal, and it can convert it into electronic form. Further, we can use some algorithm to encrypt or decrypt it all. Okay, so particularly if I talk about the NG.2 only, which use the time division, wavelength division multiplexing in passive optical networks. So in that case, the upstream is about 100 Gbps of speed. But if I talk about the downstream, it is around 40 Gbps. Yes, NG.3 we have a different type of expectations. So these standards are defined by the ITU-T. We have to follow it. In our research, we are following it, but ultimately we are increasing the capacity. Okay, they have mentioned that you have to use that much channel, but yes, we are using bidirectional. We are adopting the recommendation in terms of frequency, in terms of bidirectional communication. But yes, we are increasing. We are actually dealing with the cutting, not cutting in the leading edge technology, which will come after 10 years. As I already mentioned, these technologies are standardized by the ITU-T. Specifically, if I talk about the NG.2, it is coming under G.989 series, which is recommended by ITU-T. Okay, so you can see here the bit rate, that is 10 Gbps, 10 Gbps. This is symmetric. Symmetric means that if we are using same bit rate at the transmitter receiver side for the bidirectional communication, okay. Asymmetric means if I'm using 10 Gbps one side, 2.5 Gbps another side, that is asymmetric. Okay, they have allowed the splitting ratio to 64. We can serve the 64 remote units in the case of NG.2, but in our research we are going to the 200, 300s also. Okay, which is not standardized, but still we are doing. We want to see that what will be the performance. This was the simulation setup we have proposed. One of my PhD students is going to submit her PhD thesis on this topic, NG.2. So we have a bidirectional optical fiber. Okay, here we have used 8 transmitters, 8 receivers. At this side, we have used 8 arms of demultiplexer. Further, we have used splitter, which split 1 to 4. Okay, so 8 arms, further it is split into 4. Further, these 4 arms are connected with the ONU, optical network unit, which is user premises, which receives the data, then after that again transmit the data further. And further this data is multiplexed and transmitted through the bidirectional optical fiber and received by this receiver. That was the structure we have proposed, and it was published in Springer Journal also. This is the transmitter. It is actually the direct modulation. We are directly modulating the millimeter wave over the light signal by using Mach-Zehnder modulator. This is the receiver. We we filter out the signal first. Then we use buffer to just play with the delay. Then photodiode. Then again a filter. Then we have a eye diagram analyzer. These are the results. So you can see that we have different receivers at that part, and quality factor which should be greater than 6. And we have analyzed this setup at 10 kilometer of distance, 15 kilometer and 20 kilometer of distance. So if I talk about the 10 kilometer of distance, you can see all quality factors are in acceptable range. But if I talk about a 20 kilometer, it is like a little, bad performance as compared to 10 kilometer. It is obvious that if we are increasing the transmission distance, okay, then there will be a more nonlinear effects, optical fiber nonlinear effects, then which can reduce the performance in terms of quality factor and bit error rate. These are the results for the symmetric TDM. So one thing which you can see that even at 20 kilometer, we have the quality factor which is above 6 kilometer for all the receivers. Okay, so this setup can be recommended for the 5G front hauling. Another architecture we have proposed, which was published in Elsewhere journal, very good journal. This architecture, the previous architecture we were proposed, these were dealing with the very basic modulation techniques. But in 5G technology, we have to use the advanced modulation techniques. So for the basic experiments, that is fine. But yes, if you specifically talk about the 5G, then we have to go for the advanced modulation. So in this setup, we have performed the same idea with the QAM signal. Okay, we have produced the QAM signal. Okay, we have used 8 transmitter, 8 receiver, then again 8 transmitter, 8 receiver, and we have a directional, bidirectional communication. We have obeyed the same rules which are mentioned by the ITUT, but we have choose this QAM signal for the modulation purpose, and we got acceptable results. And this is the architecture we recently we have proposed, that was that is dealing with the PAM signal. Okay, and it is under communication. That's why I'm not showing the results. And we got pretty much good result for this structure also, which is a millimeter wave over fiber when we use the PAM modulation. One of my PhD students has done this hybrid optical wireless access network. He has already defended his PhD, and up till now, up till this area, I was working with it, and the wireless area was with another supervisor. He was a co-supervisor. In this area, we have used NG-PON2, NG-PON2 50G techniques, and we also have started with the NG-PON3 also. Okay, in this area, actually the idea was that yes, I have transmitted the optical bits, we have received the bits, further we have given these bits to the wireless person, and then they have code the different feeding with respect to that bits, and after that, after some kilometers, we have observed that we got this result or not. So that was the idea which we have implemented in this. Yes, by using relay and Russian fitting, we got pretty much good result in terms of bit error rate. So I'm running out of time. So another area in my research group which are going on backhauling of 5G networks. So we have fabricated several antennas and massive MIMO antennas. In India, I think we are only the group, according to my knowledge, which are working on this terahertz and massive MIMO antennas. And we have implemented 3 research projects. One was international, 2 was national, and we also got several best paper awards on this. We have fabricated, we have tested it, and one patent is published. We are also going for the design patents. So basically, our idea is to provide the support, front hauling support and back hauling support to the 5G technology by using optical fiber communication and by using antenna. For antenna, I have collaboration with Professor Tariqul Islam. He's a senior professor in National University of Malaysia. Yes, if I talk about the 60 perspective, okay, of course it is an advanced version of 5G, okay, but the thing is that we need to create an ecosystem for this, for 6G technology. Okay, I would like to thank the Department of Telecommunication. They have taken up the, initiation of 6G ecosystem, and they called for the proposal. I also have submitted one proposal in this because it is a need of an hour. And I also would like to thank the Department of Telecommunication for providing us this 5G infrastructure in our institute. Yes, of course, they also have provided this. Yeah, if you want to make it in 6G scenario, in 6G ecosystem, then go for it. From core of my heart, I would like to thank the Department of Telecommunication for this. So, of course, if you compare the 6G with the 5G technology, 6G technology is much, much better than 5G. But the thing is, we have to do the research. We have to exploit the 5G infrastructure first. If you have idea of 5G technology, then you can shift to the 6G. For me, it is easy. Means if I am dealing with the optical, I am not dealing with the protocols. I am not dealing because there are several other persons which I can collaborate. But the thing is, for me, I just go for the optical communication or the antenna according to the requirement. But for the protocol, who are working on protocol, this is a little bit difficult that how we can shift the 5G to 6G technology. And we are blessed that yes, we have like experts in Department of Telecommunication which can guide us in this perspective. This slide is not for you actually, you are all faculty members. So I would like to thank my team, my PhD students, my masters and BA, BTech students who helped me a lot in my research. I would like to thank my sponsor who always support me in my research. Thank you so much. Any questions, please? Am I audible, sir?
Hello.
Yes, sir. Yes,
Am I
sir. You are
audible?
audible.
Okay, okay.
Hello, sir. Yeah,
Hello.
I have only one. I have only one query, sir. This is Dr. Rohit from NIT Jalandhar.
Hi, Dr. Rohit, how are you?
Hello.
Hello, am I audible?
Yes, sir.
Yes, yes.
Yes, sir. Yes, sir. Sir, my query is in terms of simulation. So, what are the differences we may see in terms of modeling this optical communication network as compared to the previous traditional wireless network?
I'm not getting your question. Can you please repeat it again?
Yes, sir. Sir, in terms of simulation, so what are the differences we may see to model these optical networks as compared to the traditional wireless networks?
Okay, traditional means the modules, of course, that in RF communication we need a different type of components. Okay, RF antenna.
Yeah.
Okay, RF transmitter, RF receiver. In the case of optical communication, we need different type of modules. Like we need optical modulation, optical modulator, optical transmitter, optical receiver. So of course, which can play with the light, we can use in optical fiber communication. But yes, for RF communication, we need a different component. So these two areas are totally different. Yes, you can combine these two areas, but in different modules. You can't say that it will be combined to one module only.
Yeah.
Thank you.
Thank you very much.
Yes, Mr. Sanjay, am I audible?
Yes, yes. Go ahead.
Hello, Namaskar,
Go
sir.
ahead, sir. Go ahead, sir.
I think I should join from my mobile phone. I am facing some problem in my iPad. Just a minute. Am I audible? Yes, please.
Madhukar, he's not able to. नहीं, मैंने लेना नहीं था। अच्छा चलो आप ले लो ना, है ना? करते मधुकर कोई इशू आ रहा है?
No issue, sir. Actually, I think Dr. Simranjit Singh is not online.
So he said no, he'll be joining using mobile perhaps.
Yes.
Ji, am I audible?
Yes, sir.
Yes, sir. Any discussions, any questions, or any suggestions, please? Sir, please unmute yourself. Ashok, sir.
Yeah, I was saying same thing. Participants are requested to ask any queries, questions, the topic which he covered.
Or you may search my name over the Google and you can have my email ID if you are not comfortable to ask questions on the common platform. You can contact me directly because I, as a part.
सिमरन जी आपका आवाज फिर गायब हो गया. I think there's some issues.
Yes, sir. I think there is.
Now
there
it is okay. Now it is okay.
Okay.
Yeah.
Okay.
So any question? I think it's a good time that we can interact with him on some of the aspects which he covered in his lecture.
Sir, I want to ask something to you that we need your help, sir, in industry point of view. So we are
Okay.
working on optical communication. We are working on antenna. We are just selecting a frequency. Yes, IEEE is saying this. ITUT is saying this. Government of India is saying this. We are doing it on that basis only.
Okay.
But we need your suggestions on industry point of view. What you are expecting from the side of optical communication or antenna design, on which we can work on.
Okay. I think Department of Telecom has funded a test bed on optical communications. I think that is being hosted with IIT Madras or Samir. I'm not very sure, but Chennai.
IIT Madras, Professor Deepa Venkatesh.
Yeah. So I think that will be a good platform to interact with, because if you can also somehow connect with them and join, so I mean it can be integrated along with what they are trying to do. So that is one. Secondly, if you look at, I mean, industry perspective, industry in the sense that uh, on optical fiber, the users are operators, right? In India, all the operators use optical fiber network for their connectivity. So they always go on a very proven commercial product. But yes, if suppose you develop something which need to be piloted in some of the commercial network, that part perhaps we will be able to facilitate either through BSNL or maybe through some of the private operators. That suppose somebody develops a technology which can give me a higher speed on a connected link, or somebody develops something related to quantum, right? So in a lab environment it is fine. Can we put it on some commercial network? So in that aspect, we'll be able to help to large extent by coordinating and asking operators, especially BSNL will have a better say, being a public sector unit. So there we can do some sort of POC or trial kind of thing on all the telecom technology, not only on fiber or quantum, but whatever we are able to do as a product.
Okay.
Yeah. So let
Sir,
us know. I think in your area also we have got a field office. We call it LSA, license service area. So there also you can like interact with them and they can facilitate. Otherwise, we are here. So I think our coordinates are already with you. So
okay, sir.
if you think that some intervention from this side will always be available. Yeah.
Thank you, sir. Thank you so much. And I really appreciate your efforts for 5G labs and the 6G ecosystem. Means,
Yeah, I think we are trying to. Uh, I mean, it is for the first time. You may recall that in India during 5G time, India submitted its own 5G technology in IT. So this was for the first time that some Indian technology, whatsoever it is, is there in the standards, right? Otherwise, we were just a followers. Similarly, if you look at 1M, 2M standards, a lot of Indian stuff is there in that. Now 3GPP also we have started participating, many companies and organization from India. So maybe our aim is that even if you are able to uh, have 10% of the IPR of 6G as an India IPR, so that will be a great achievement. So in that direction, only government is trying to put 6G lab, terahertz lab, optical fiber lab, and trying to fund many like startup researchers who are trying to do. You might have seen a lot of things coming as part of TTDF, and also last date was yesterday related to 6G some proposals. So they are also, we have got 400 plus applications in that, and from various companies, institutions. So that shortlisting will go on. So we'll try to, I mean, choose some of the project which can become some sort of part of standard or can be commercialized, and try to fund to a large extent so that we have something before 6G can be rolled out. Yeah. Thank you.
thank you, sir. Thank you. Thank you, sir.
So over to you, Madhukar, for vote of thanks.
Yes, yes, sir. So it is time to thank Dr. Simranjit Singh. Dr. Singh, please accept our sincere thanks and deep gratitude from our team and on behalf of all the participants for taking this session on very pertinent topic. It was very pleasant and informative presentation. Your contribution has brought diversity to this FBP and enriched the overall content. We also thank all the participants for taking their valuable time in participating in this session and making the session interesting. We always look forward for the further session from the Dr. Singh also. So thank you, sir. Thank you for your valuable time.
My
Thank you
pleasure,
for
sir. Pleasure is mine.
Thank
Thank
you,
you.
sir. So next session will be on 2:30. Um, I think Ashok sir may kindly enlighten some point regarding this session.
So I would request that today, right now we have 100 plus participants hooked in. So I request all of you to join 2:30 session that is about end to end